So the Earth's oceans have just turned from water into ink overnight. Ignoring all the implications this has for all marine life, and in fact for our entire planet as a whole, let's just ask the more important question. How many pens can we fill? And if you can work that out, how many words can you write and how far could we reach with the ink from all those pens? First, let's compute how much one pen can write. So the dimensions of an A4 sheet of lined paper are 210mm by 297mm. Or, apparently it is, but when I measured my sheets, I get 20.7cm, so my notebook is lying to me by about 3mm, and I want my compensation. Anyways, it doesn't matter, because we aren't getting even our full line's worth of writing anyway, because of these pesky margins. No, I refuse to write anything besides bullet points in these margins, so for this calculation, the margins remain clean. If you choose to write anything into these margins, that's fine. Don't blame me when you're arrested by the UN for breaking the Geneva Convention. Measuring the margin, I got 2.9cm. 20.7 minus 2.9 gives us 17.8cm of line length. The height of one line is 7.1mm, or 0.71cm. Or at least that's what it says online, but when I measure my notebook, I get 0.71cm, or... Oh wait, I agree. Apologies, notebook manufacturers. Now, the average length of a word in the English language is 5 letters long, and the average number of words per line, based on a sample of 50 pages of my GCSE English book, is 18. But considering the size of people's handwriting can vary from, please for the love of God, stay within one line, to only readable with an electron microscope, let's say it can range from 12 to 21 words per line. So an average of 16.5 words per line. Now, 16.5 multiplied by 5 gives us 82.5 letters per line. 17.8 divided by 82.5 gives us 0.216 centimeters of length per letter, or multiplied by 5, 1.079 centimeters per word. The height can also vary, but I would presume less than the number of words per line. Assuming the height of each letter is about 70 to 95% of the height of the line, and taking the average to be 82.5%, we get the height of one letter to be 0.58575 centimeters. According to a study from the University of Reading, not reading, a pen can range from a writing distance of 1,000 to 2,000 meters. To write the average word, the pen must travel 5 times the length of one letter and 5 times the height. So, 5 multiplied by this sum gives us a distance of 4.00875 centimeters per word. Converting into meters and dividing 2,000 by this quantity, we get 49,890 words per peak pen. Doing the same for the lower bound, we get 24,945 words per worst pen. Now we're going to split this problem even further, as there are 2 distinct kinds of pens. Your standard big pens and your fancy schmancy pens that always smudge all over the page and get ink all over your hands. You know the kind. Yeah, those ones. Anyways, taking my own measurements from an array of different pens I had lying around the house, I get the diameter of the ink tube to be 0.3 centimeters, and its height to be 11.7 centimeters, the height being the height at which the ink starts for a fresh pen. Using the formula for the volume of a cylinder, we get a volume of 0.827 centimeters cubed, or 0.827 milliliters of ink. For our dumb fancy pens, we have a much thicker tube of diameter 0.5 centimeters, but the ink only fills a height of 10 centimeters. So, this equates to 1.96 milliliters of ink, of which 30% will be smudged all over your hands, though this won't be factored into the calculation. Great, now that's done, we can work out how much ink we have. Luckily for us, we don't need to calculate the volume of Earth's oceans, as according to the US Geological Survey, the volume of the ocean is approximately 1,335,000 cubic kilometers, which translates to 1.335 times 10 to the 18 liters. If you're not comfortable with scientific notation, that number just means this. Well, we just move every decimal forward by 18 places. That is now our volume of ink. That's a lot of ink. Now, with this ink, we could fill up 1.614 times 10 to the 21 big pens, or 6.811 times 10 to the 20 fancy pens. So, those are some pretty big numbers, the scale of which we can't possibly comprehend. But, for reference, the dimensions of a big crystal pen are 14.4 centimeters by 0.7 centimeters. So, the volume, assuming it to be perfectly cylindrical, which it obviously isn't, would be 5.54 centimeters cubed, The volume of a giant cylinder of all of these pens, or a pen skyscraper if you will, would be 8.94 times 10 to the 15 cubic meters. The mass of one of these pens is only 10 grams, so our skyscraper of pens would have a mass of 1.614 times 10 to the 18 kilograms. To put that into scale, the mass of the Earth is 5.973 times 10 to the 24 kilograms. Oh wait, never mind, that's a million times difference, not a good comparison. Well, aha! The mass of Mount Everest is approximately 357 trillion pounds, or 1.619 times 10 to the 15 kilograms. So our pen monument. Sorry, it feels like there's an obvious pun I'm missing right there. Penument? Monupen? Never mind. Where was I? Right, our pen monument is the mass of 1,000 Mount Everest. We are nearly done. With 1.614 times 10 to the 21 big pens, we can write 8.052 times 10 to the 25 words, assuming that these pens are all peak condition. Those are more words than have ever been written in human history, probably more than will ever be written in human history. Now remember, one word equates to a length of 1.079 centimeters, so if we were actually writing, we could write a total distance of 8.69 times 10 to the 23 meters, or 91,800,000 light years. A light year being the distance light travels in 1 year. Go figure. The distance to the sun is 149.6 billion meters, or 1.496 times 10 to the 11. So, with our pens, we could write from the Earth to the sun 5.81 billion times. But this length is still just over 1,000th of our observable universe, which is 46.5 billion light years, or 4.4 times 10 to the 26 meters across. But what we just did was actually right. But who actually likes writing? Put your hands down. So, let's just draw a straight line. The total distance per word was 4.00875 centimeters per word. So, multiplying our result by this factor, we get 3.48 times 10 to the 24 meters, or, deep breath, 367,836,290 light years. But how long would it take someone to write out all those words? Well, the average rate of writing varies from 5 to 20 words per minute when copying out. So, the average is 12.5 words per minute. Working this out, it will take 6.42 times 10 to the 24 minutes, which is equivalent to 1.22 times 10 to the 19 years. For reference, the age of the universe is 14 billion years, or only 1.4 times 10 to the 10 years. So it would take 871,896,830 universal ages for one person to do it. Also known as a very long time. If we were all inducted into this menial task by a race of cruel aliens, how fast could we do it? Well, our population is 7.753 billion strong, so if we were all doing it, we could complete the task in 1,573,584,419 years, or 1.57 billion years. So, less than the age of the universe by a whole order of magnitude. But of course, we would all die out by that time. We could factor in working times, like only 8 hours of effective writing per day, but I don't want to. So, here's a picture of something funny. Oh, what's that sound? It can't be. I think it is. It's a bonus question. So, someone in high school once told me that I can write so much in my essays, I could probably fill the Grand Canyon with my words. I won't say who, in case this person's watching. Bethany. For legal reasons, I must say that was a joke, and this is not the person in question's real name. But that got me thinking. How many words would it take to fill up the Grand Canyon? Obviously, words are not 3D objects, but if we count the depth of the paper, then we can do some working out. Suppose we cut out each word in a perfect rectangle. The area of this rectangle is 0.632 centimeters squared. To get the volume, we multiply by the thickness of the paper, which is 0.1 millimeters, to get 6.32 times 10 to the minus 3 cubic centimeters. The volume of the Grand Canyon is 4.17 times 10 to the 15 liters, so we could fill it with 6.598 times 10 to the 19 words. That's a lot of words as well. We could throw 1.12 times 10 to the 12 copies of the Twilight Saga into the Grand Canyon. Fortunately, that many copies don't, and will never exist. Doing similar calculations, we could fill our newly emptied oceans with 2.112 times 10 to the 22 words, or a 1 litre bottle with 15,832 words. So we've successfully created a new system of units, the literary units. It is also a very versatile system. Words can be a unit of volume, 15,832 words being 1 litre, a unit of distance, and if we want, a unit of time as well. All in 91.8 million light years work, eh?